sample size by the ordering method and eliminate the specific gravity, water absorption, moisture content, and densities of fine aggregates.
So the objectives for experiment number 5 are to determine the specific gravity, water absorption, moisture content, and densities of a sample of fine aggregates into testing sizes by ordering method. Second, to be able to discuss the results derived from the data collected in the experiment. The materials to be used are fine aggregates, flat edge shovel or trowel, tin can, rectangle container, sieve number 4, and mixing pan. The lab equipment to be used are weighing balance, drying oven.
The first step is to obtain the mass of the containers. So in order to do that, weigh all empty containers on a weighing scale and note their mass.
And now we will start to reduce the sample size by using quartering method. First, place sample of fine aggregates on a clean flat surface. Next step is, by the use of shovel, mix the sample by turning it at least 3 times, forming a cone.
Flatten the pile by pushing it straight down.
Divide the pile into quarters. Discard the diagonally opposite quarters. Repeat the procedures 3 to 8 until the desired sample size is achieved. So we move on to the after quartering method. The first step is to sieve the sample using the sieve number 4.
Choose 3 samples from 6 to be saturated with water. Make sure the sand is absorbed, but remove the excess water after.
Weigh and record the final mass of the selected 3 dry samples and 3 wet samples. Samples in the drying oven for at least 24 hours.
So after oven drying, we will now get all the samples and then weigh. Now get the weight of each sample.
After the cooling period, immerse the sand in water at room temperature for a period of 15 to 19 hours. sample from the water, avoiding loss of fines. And then spread the sample on a flat, non-absorbent surface, and then stir the sample occasionally to assist in homogeneous drying.
And now we will dry our samples.
So after oven drying, we will now get the SSD weigh. If there is no pygnometer, calibrate a container by filling with water to calibration line.
And now we will now look for the weight for each container filled with water. Fill the container with SSD sand and water to 90% of the container.
Roll, invert, and agitate the container manually to ensure entrapped air is eliminated. Record the weight as weight of container with sample and water.
So now we will put again the sample in pan for getting the oven drying. So now we will put the sample in the oven to get the final oven drying.
Take the tin cans out of the oven.
Now we will wait for the oven dry weight.
Regarding the specific gravity, the average of the bulk specific gravity SSD of the 3 samples is 2.5841. Average of the bulk SSD specific gravity indicates the weight of a unit volume of aggregate in air, taking into account the weight of water in the voids that has been filled after being submerged in water for about 15 hours. Also, the average bulk specific of the sample is 2.5284. Based on our research, the specific gravity of fine aggregates is considered to be around 2.6 to 2.9. Knowing the specific gravity is necessary for us to determine the volume of solid aggregates and the percentage of voids. Regarding the discussions of moisture content and water absorption, in our absorption, we got the average absorption of 2.186%. Absorption is the increase in mass due to water in the pores of the material. In our research, water absorption should not exceed 3% or 2% in critical condition. Aggregate strength can be estimated from water absorption. In general, unless they are shown to be suitable based on strength, impact, and hardness tests, larger porous aggregates with a higher water absorption rate are regarded as undesirable. For density, the approximate bulk density of aggregate that is commonly used in normal weight concrete is between 1,200 and 1,750 kg per cubic meter. Based from that statement, we can observe that our value lies between that ranges. The weight of the aggregate is influenced by the moisture content of the aggregate, which is why it is required to have a constant moisture content.